Okay, we will get started. Hello everyone, thank you for attending. My name is Kevin Goff, and I frequently do presentations and write articles along a theme of a 13-tip format, and for years I've been calling it the Baker's Dozen. And this particular presentation is the Baker's Dozen, 13 Excel features that application developers should be aware of. So we will get started here. First of all, just a very brief bio. As Dan mentioned, I'm a SQL Server MVP. I mainly speak in the Mid-Atlantic area. I'm actually going to be down in Orlando next week for the SQL Live conference in Orlando, Florida. The only thing you need to write down here is my website address and optionally my email address. The slide deck is already up on my website. It's actually www.kevinsgoff.net. So if you go to that site, I'll even go to it right now to show you where the download is. It's just www.kevinsgoff.net. We'll pop up a browser here, and once my website comes up, over the right-hand side there are a list of categories, and one of them is downloads. So just go to the download page under categories, and it's the very last download here, 13 Excel tips for developers. So just click on the link, and that'll pull down the slide deck. I posted it right before we started here this morning. Feel free to check out my website. I've got webcasts. I've got other downloads for other topics. And if you have any questions about anything, feel free to email me. My email address is kgoff@kevinsgoff.net. That's kgoff@kevinsgoff.net. I'll put that back up toward the end here. Okay, so today's topic is, again, 13 Excel features that developers should be aware of. Well, this, depending upon who you talk to, might be somewhat of a controversial topic. Some developers may sort of scoff at this and say, well, Excel, that's the end user world. We don't really need to worry about that. Or, why do I need a session on this? I can go in Excel and figure things out for myself. And I know that for a very long time I pretty much thought the same way. Well, over the time, and because I work in the data warehousing and the business intelligence world, I wind up running into a lot of situations where people use some of the more advanced features in Excel to do something with the data that the data team and I are providing. So it's a good idea just in general to have awareness of how people are using the data in Excel. Sometimes people might be prototyping. Business users as well as developers might use Excel for prototyping for what will eventually become a larger reporting infrastructure. So Excel has a lot of value for a lot of scenarios for many different types of people. Excel for developers is a good prototyping tool for reporting and even for sanity checking data. Many times after I publish an OLAP cube or build some new views or build some fact dimension structures in a data mart, I'll use Excel to sanity check some of the information. And I even have a few personal projects using Excel and even Power BI with Office 365 because of the enhancements that have come down the road to push Power BI content from Excel up into the cloud, so to speak. So I'm even a consumer of some of my own sort of personal projects. So many reasons why it's a good idea to know what's in Excel. Now here are the topics we've got on the menu today. Now first of all, I am very confident that just about every attendee knows and has used at least some of these. But there may be individual topics that you might never have seen before. Maybe you're aware of it but never looked at it, or maybe you weren't even aware of it. I know that even as recently as a year ago, I wasn't aware of some of the features that were in goal seeking in Excel, and had a chance to work with it and found that there's some pretty interesting functionality in there. So we're actually going to start off by some of the what-if capabilities and specifically targeting goal seeking in Excel. Going to look at the VLOOKUP function and some of the do's and don'ts with that, and that's actually going to flow into the third topic, which is named ranges. Very often when we use VLOOKUP, we need to use name ranges to work over a range of cells, and there's some do's and don'ts with that. Then we're going to look at a feature that's almost synonymous with Excel, and that's pivot tables. Now, because of what Microsoft has done over the years with functionality like PowerPivot, there's now multiple multiple ways that you can get at data depending upon what you want to use as a data source, whether you want to use the PowerPivot functionality. So it is important to understand that the pivot tables have been in the tool for a long time, but you can now leverage them with PowerPivot content that I'll get to a little bit later. So we'll take a look at some pivot table functionality against both transaction databases as well as OLAP cubes. We're going to look at some of the pivot table options that Microsoft has available. Some of these have been in the product for a long time, and others more recent functionality. We're going to take a look at pivot charts and Sparklines. Sparklines is a special type of chart. It's a highly compressed chart, not used to. And along with that, we'll also take a look at some dynamic coloring of a pivot table that's using Sparklines, and also how we might use a macro to repeat some of the dynamic coloring features that we put in. Then we're going to look at PowerPivot, and PowerPivot actually winds up having its own information tree on its own. It's hard to talk about PowerPivot without talking about some of the things that you may need to use with PowerPivot, like DAX to create expression formulas. So we'll take a look at PowerPivot and also how we can enhance it with DAX. Also take a look at PowerView, which is Microsoft's newest self-service reporting tool inside of Excel. So you see at this point that Excel has really grown up. If you go back before 2010, almost half of these features don't even show up on this list because they weren't even available at that point. So you can see how much Excel has grown up over the years as a tool for any type of self-service BI. We're also going to take a look at how we can incorporate MDX code into pivot tables. Now, this is only going to apply to specific situations. The scenario is going to be that we're building a pivot table or pivot chart against an OLAP cube, and we'd like to come up with some custom calculations, and we can't touch the cube. So how can we put custom MDX into the sheet, much in the same way you might put custom MDX into a report. Then we're going to look at a special type of pivot chart, one that doesn't necessarily fall into the mainstream. And then at the end, I've got some links. And ways that we can exploit them in Excel. So some basic functionality here and some more advanced stuff. So hopefully everybody will get at least a few things out of it. So I'm going to start off with kind of a simple one, but one that I've definitely used from time to time, and it's what if goal seeking. Now, the most common example that you see with this, if you look up on YouTube or any website, you'll see one dealing with payment and interest payments and interest rates. That's the most common one, and I'll show an example of that. But I've got one that's even simpler. Let's take as a very, very simple example. Not even going to bring data in from a database. We'll just simply put in some simple values. Let's say that I got to take X number of tests to pass a course, and my first couple of tests I score 91 and 85 and so on, and then I'm up to my fourth test, and I know that I need to score an 85 overall across all the tests in order to pass. So what's the lowest score that I can get on test 4 and still clinch at least an 85? Well, clearly you can do this in your head or with some simple formulas, but there is a feature in Excel that allows us to do that. Now I'm going to take the Julia Child approach here. I've got a finished version of these, and then I'm going to build some of these examples from scratch. So I've got a couple of tests here, and I want to be able to plug in a what if formula and see what's the lowest I could get and still score an 85. So what I'm going to do is I'm going to actually open another copy of Excel here, and I will paste in the raw data from the first example here. So bring in everything here, but I will wipe out the average and wipe out test 5. So here are my first 4 test scores. Now, before I put in any kind of a goal seeking on test 5, I need to establish the formula that's going to run at the end. Sometimes people jump the gun and they go to test 5 and they go to the data option and they try to put in the what if analysis and try to do some goal seeking, but we've skipped a step because we have to put the final formula in for the average before we can actually go to the goal seek. So first thing I'm going to do here is I'm going to come down to the average, and I'll just put in the formula here myself. I'm going to do an average of of basically C5 to C9. And right now it gives me an 86. It actually doesn't record test 5 because I have a null value in there, so it doesn't count that one. But I want to know, obviously if I do really badly, if I score a 40 here, then I'm way below the average. So what's the lowest I can get and still target the average of 85? Well, what I do here, I go to the Data tab, and under Data there's an option for What If Analysis. And under What If Analysis there's an option for Goal Seek. So I'm going to take Goal Seek. And this prompts me for 3 pieces of information. First of all, what are we looking to target at the end? Well, that's basically what's in cell C13 there. And we want it at the end to be an 85. It almost seems backwards because, in effect, we are sort of reverse engineering to try to come up with what's the lowest score that we can get and still score an 85. And then what we want to target here, what we want to find out is what's going to be in cell C9 that will give us at least an 85. So I'll just point to cell C9, and that actually calculates and tells me that I can score 79 and still wind up with the 85 at the end. So, like I said, the first time you ever do this, it almost seems counterintuitive, but if you think about it, we're reverse engineering this, but we have to tell Excel specifically what the formula is and then what area we want to actually hit. Well, the more common one that you'll see is one dealing with loan and payments for a particular interest rate. Let's say that I want to take out a loan for $20,000 and I want to pay it back over 60 months, over 5 years, and I know that I can afford $400 a month. So, what interest rate should I be looking at? Well, again, I'll copy these, come over to my new copy of Excel, and let me get rid of these here. So I know that I want a loan of 20 grand over a period of 60 months. Well, once again, just the same way I did with the average, I need to tell Excel what the formula is for the monthly payment. Now, fortunately, Excel has a number of formulas and an interface built in. So what I'm going to do is I'm going to go to the financial formulas and come down to payment. And in the payment area, it asks me what rate, what column represents the rate. Well, it's going, and there's one thing we need to keep in mind here. Notice the note. If we're doing quarterly payments, we need to put in the value divided by 4. So I actually need to put in basically cell D3 divided by 12 because these are going to be monthly payments. And then the N per is the number of payments. Well, that's going to be in cell. That's going to be from cell D2. And then the total payment, the present value, is basically the amount of the loan. So that's going to be in D1. Now I could have put that payment function in myself up there in the editor bar, but I'm using the interface here. I'll take OK. Now this in itself doesn't tell me what interest rate we need to target because we need to tell it that we can make payments of $400 a month. So now that I put the formula in, what I'll do is I'll go to the Data tab and I'll go to the What If Analysis, and I will do some goal seeking here. And again, I want to tell this that I can make a payment when it's all said and done. I can make a payment in D4 of $400 a month. Now I have to put in negative $400 because that amount is coming out of the principal value of the loan. And we want this to calculate what's in cell D3. So I'll take OK, and that tells me that for $400 a month I should be shopping for an interest rate of 7.42%. So those are two simple but meaningful examples of how we implement what if analysis and goal seeking in Excel. I've got a couple of clients who use this type of feature for modeling. And the first time I've ever actually looked at this or became aware of it, I was actually sort of doing this manually, and I actually had somebody say, you can do that in Excel. Well, it's always embarrassing when you find out that there's a feature in a tool that can do it for you, but it's always good to know. Okay, so starting off with a basic one here, and by the way, the slide deck has some of the talking points here So if you pull the slide deck down and want to review this, I have some of the same notes in here in the slide deck. All right. Well, next thing we're going to look at is a function that probably everybody has used at one point or another in Excel, and that's VLOOKUP. But even if you use it, there might be a couple of things dealing with the specific parameters that are good to know. VLOOKUP essentially allows someone in Excel to look up a value into a range of cells and return another value. So very, very simple example here. Let's say that I've got a grade scale of 90 and above is an A and 80 above is B, and between 80 and 90 is a B, and so on. And I've got a couple of test scores here. You know, I got an 84, somebody got a 91, and somebody got a 78. So we want to implement a lookup to query into this range of cells to bring back the grade letter. Well, there's some do's and don'ts with this. There's some ways that we can do it that are right, and there's some ways that we can do it that might initially appear to be right, but might not necessarily be good in the long run. So as I take a look here, and I'll come over to the example in a minute, but I'll take a look here for a second. We might use the VLOOKUP function to point to a particular value, like in this case cell F11, which is my test score, and then look it up into that range of cells here and bring back the second column. We want to bring back the grade letter. And we also have to tell it whether or not this is going to be an exact match or an approximate match. There is no .84 in this list here, but there's an option that we can specify for whether or not this is going to be a hard lookup or basically a soft lookup. Well, I might put in this formula, and it might seem to work, but then I might copy and paste it to other scores, and I run into a problem that we'll see in just a minute here. So come over to Excel, and I have these grades here already, so I'll just copy and paste them into my new sheet. And I'll put the grades here. So for myself, I'll put in VLOOKUP. If I could type here today. And I want to do a lookup based upon my grade. And I want to look up into the range of cells here. So I'll specify the range of cells. And then it asks, what column do we want to bring back from that range? Well, I want to bring back the second column. And then the fourth parameter is the range lookup. And the possible values here, and it's kind of odd how these work, false means an exact match and true means an approximate match. Well, I want true here. So I'll put in true. Well, that brings back a B, and that seems to be fine. Well, I'll copy and paste this, and it worked correctly for Steve, worked correctly for Mike, but for John, it bombed here. And we might initially think, is there something with the range here? Well, actually, no. Let's take a look at what happened when I copied and pasted the formula. The first one up here, we were pointing to F11, and we wanted to read the range of A3 and B7. We always want to read to that range. But look what happens by the time I come down to the next one. It's looking at A4 and B8, and then A5 and B9, and then A6 and B10. As I copied and pasted that formula, as it continued to point to the next row for the score, I wanted to stay constant on the range here, and it didn't. It continues to increment that. Well, that obviously isn't what we want. Well, there's two ways that we can fix this. One way, coming back to the slide here, you can actually lock the reference to the row by putting a $sign in front of it. That basically freezes the reference. So what I'll do here is I'll do the same thing. I'll once again say VLOOKUP, and again I want to do it on my score here, and I'll pick the range again. But I'll put a $sign in front of the 3 and the 7, and the same thing is what it was before. I want to bring back the second column, and I want to do an approximate match. Well, that continues to work here and here and here, but now it also works at the end for John, because if you'll notice, the range stayed the same for that cell range for the grades, A3 and B7. It didn't move. So that's one thing to be aware when you copy and paste formulas. If you want to continue to point to an exact range of cells, you want to make sure to freeze in this case the row numbers. There is another way that people might do this. Coming back to Excel, we might give that list of cells a name range. We might just call it grade range and then refer to that instead of the range of cells. I personally prefer to do that. Both ways work here. I prefer to use the name range feature. So what I'll do is I'll highlight my range here, and then up in the name box I'll call this grade range, and then I'll do the same thing here. I'll do a VLOOKUP again, but this time I'll point to that name. So I'll do a VLOOKUP. I'll start on my score. I want to point to grade range, and notice how the minute I type GR I get statement completion here. I want to bring back the second column, and I continue to want to do an approximate match. That also works for the other ones. So there's one wrong way to do this and at least two correct ways to do it. Now, if we had been looking up, product keys or something where we want an exact match, we'd obviously change that fourth parameter from a true to a false if we wanted to have an exact match. So that's VLOOKUP along with name range. It's certainly not a complicated feature, but one where you want to be careful in particular with the range of cells. All right, moving along here. Now we're going to take a look at pivot tables against data sources. Now this is one that has become a little more complicated to talk about now versus 6 or 7 years ago because there's now PowerPivot in the mix. So some people who are new to Excel wonder what's the relationship between pivot tables and PowerPivot. The one thing to keep in mind is that you could do pivot tables for years against data sources before PowerPivot came around. But PowerPivot certainly provides some additional capabilities. So we're going to go back to the beginning and look at pivot tables. Now, we can create pivot tables or pivot charts against relational databases, relational views, or OLAP cubes. So some people might create pivot tables against views that have been created in SQL Server for them, and other people might go against OLAP cubes. Now, all the data stays in the source. Only the results of any particular query come into the pivot table or the pivot chart. And for years, this was the standard way to create analytics in Excel against data. Now, we'll see in a little while how PowerPivot changes that. So, taking a look at one example here, and I'll recreate it in just a second. I'm going against the AdventureWorks OLAP cube. Now, AdventureWorks has fact tables for things like internet sales and reseller sales. Well, I've pointed to the reseller's fact table in the AdventureWorks OLAP cube, and I've brought in the product hierarchy so I can expand categories, subcategories to get to individual products. And I also have a filter here on the fiscal year, and I can also have visual slicers here for things like country and the reseller business type. Now notice at the top I've got a filter with a drop down for the year, and I've got visual slicers here. These are both filters. Functionally, a filter is a filter. It's just that with a slicer you get a little bit more of a visual aspect to it. You obviously want to be careful about picking one that's going to display a large number of items, but I'll get to that in just a minute. The other thing in here that we'll see when we build this, notice this percent of parent. You might think that this comes from a calculation in the cube. Well, actually, Excel has the ability to let us redefine, to drag a measure in a second time, and then redeclare how it's calculated. This percent of parent is actually the reseller sales measure repeated, but then redefined as a percent of whatever the row parent happens to be. So it works right there in Excel. So very quickly to create something like this, come over to my blank sheet in Excel, go to a new data tab, and I will go to the data drop-down, and I will connect from other sources and from analysis services. And I'll specify my local SSAS server, which just happens to be localhost SQL 2012. And I'll take next. And I've got many cubes out here. The one that I'm interested in is the AdventureWorks OLAP cube. And specifically, I want the AdventureWorks cube itself. There are many cubes and perspectives in here. I want just the core AdventureWorks cube. And then I'll take next, and finish. And this will save off an Office data connection file. It's basically just XML as a glorified connection string. And I already have one out there. I'll just say yes. And I want to create the pivot table. Now, I'm not going to make it look quite like this. I'll just functionally get to the same result. Well, the first thing I want to do is bring in the core measure, the reseller sales. Well, there are many fact tables here in the queue, but I want to go in specifically to the reseller sales fact table. And I will pick the measure called reseller sales amount. Now, that brings in the aggregated $80 million across all data in the AdventureWorks cube. This did not bring in all the data into Excel. It simply called a query back in the cube and brought back the aggregated amount. Well, I want to break this out by the product hierarchy. So what I'll do is I'll go over to the pivot table field list, come down to the product category hierarchy, and I'll check that. And that puts it in the row axis right away. So I can expand accessories, and I could expand bike racks, and I see there's just one product under bike racks. I could expand helmets, and I see there are many products under helmets. So if this had been a geography hierarchy with country and region and city and so forth, we get the drill down capability right out of the box. Now, I want to be able to show that reseller sales and show it as a percent of whatever the row parent happens to be. So what we do here, down in the pivot table field list, I'll come down and I'll take the reseller sales amount and I'll drag that down in the value quadrant here a second time. So I get reseller sales amount 2. But then in the lower right hand corner I'll click the drop down and I'll go to value field settings. And we see that there are a number of ways that we can redefine that particular value. We can redefine it as percent of grand total, column total, row total. We can even implement ranking if we want, which is a really nice feature. I'm going to specify percent of parent row total because I have a variable number of hierarchy levels in here. I might have 4 levels of products. I might have 7 levels of products. I have no idea how many levels I have. I simply wanted to calculate the sales with respect to whatever the parent happens to be. And also change the custom name here to percent of parent and take OK. Notice what that does. That immediately calculates percent of parent. So accessories, just a very small amount, bikes, a very big amount, clothing and components fill in the rest. Well, I'll expand components here, and I see that all of these values add up to 100% or maybe 99.99 because of rounding. And if I were to expand any one of these like cranksets, I have 3 cranksets here, HL, LL, and ML, and their percent adds up to 100. So it's calculating the percent of the row parent in each case. Now, by default, this comes in ordered by the original order of the hierarchy. Well, in every case here, I want to sort by the reseller sales amount within the group. I actually have to do this 3 times. If someone is aware of a way to do this once, I'd love to know. What I'll do is at the top level, I'll click the drop down beside the row labels, go to more sort options, and I'll sort the category level by the reseller sales. Well, now I get bikes at the top. But if I expand bikes, well, mountain bikes, road bikes, and tour bikes are still alphabetical. What I have to do is go to the second level, click the drop down, and now I'm sorting the subcategory level. I'll go to more sort options and change that to reseller sales amount. And now they're high to low. And then to get the product level, I'll go on the product level, click the row label drop down. Notice how the select field is automatically set now to product. Go to the more sort options and sort that high to low. By the way, if I wanted to do something weird and maybe sort the lowest level ascending, I certainly can. It'll keep track of all of it. So if we've got multiple levels, that's how we have to sort it. If there's a way to do it with just one set of keystrokes, I'd be interested to know. All right, now the other thing we did here is that we put the country and the business type as visual slicers, and we also specified a filter here. Well, I'll do the filter first. I'll come over here to the date dimension, and this particular database had calendar and fiscal definitions built in. So however many levels you've specified for a hierarchy, in this case for a date hierarchy, is what we're going to have available here. Well, I'll take the fiscal hierarchy, and I'll drag that into the filters quadrant. Well, that means that I can pick anything in here. I can pick 2008, I can pick the first half or the second half, I can pick one of the quarters, I could do a multi-select if I want and pick the first 2 quarters of 2008 and then maybe the third quarter if I want. I'm just simply going to pick the year. And the numbers refresh right away to reflect just 2008. Again, it's firing a query back to the original source, in this case the OLAP cube. Now, these filters are usually going to work pretty fast. I'm also going to bring in the country and the reseller type as slicers. So what I'll do is over in the pivot table options here, I'll come down to the geography dimension, and I will take the country, and I'll click the drop down out to the right of country. And I'm sorry, not the drop down, but I'll right click on the country, and I'll say add it as a slicer. And it automatically throws in all of the countries. Now, this is great when you have a handful of items, or maybe a few dozen. If you have cities and you have thousands of cities or tens of thousands or hundreds of thousands of accounts, I really would not recommend doing that. Slicers are best when we have a fairly short list. Something that's there's no magic number, but certainly something that's in the thousands or higher. I would probably not recommend using as a slicer. It's better off being a filter. Now with a slicer, I can pick one country. I can do a shift click and specify a series of countries. I can reset the filter and get back to all countries. Now I don't know if it will demonstrate it here, but let me pick FY 2010 here. All right. Notice how if I pick something where any one or all the countries isn't available, they'll actually be disabled. Let's say for a minute that FY 2010 had data for Australia but no other countries. The other countries would be disabled. So these slicers actually do have some intelligence built into them. And then if I want to get the reseller type, I can come down here to more fields and specify the business type as a slicer as well. And now I can break this out by just reseller sales that went through warehouses. So a lot of navigation capability here. I use this very often I turn around and make myself a user when I'm sort of sanity testing data coming out of a cube or out of a data mart. A lot of great functionality here. So that scratches the surface of the surface, but it gives you an idea of what we can do with pivot tables. Now this next one, because I want to make sure I get through all the content here, some of these I'm going to speak to. There's another capability that we have in here, and that's the ability to combine a pivot table with a pivot chart. What I'll do here is I'll go to the end result. I won't build this one from scratch. I'll go to the end result. So I will go search for this one. So bear with me 1 second here. Yeah, here we go. I've got a pivot table where I brought in the cities. So if I bring my field list back here. From reseller sales, I brought in the cities into the row axis, and I put a geography filter up here at the top, and I'm looking at the cities in Washington. And I also have a pivot chart beside here. Now, all I had to do to get a pivot chart beside this after building the pivot table was simply, with the pivot table selected, was to take Insert, and then over in the chart area in the middle, just pick whichever pivot chart I happen to want. But I've done something a little different here. I don't necessarily want to graph all the cities. I might have many. Maybe I want the best 5, and then maybe an all other. Now I'm going to, 1 second, I'm going to change this to an Oregon. That was one I was using in the example. And I'll fix this formula here in just a second. What I want to do is get the top 5 and then get an all other and lump them into just into one number. Well, notice how I've got basically a downgraded pivot table. I basically took the references to cells A4 down to A8 and copy them out here, and the same thing with B4 and B8. So that gives me the first 5 here in the list. This list is sorted by the reseller sales amount. The all other here had a formula that bombed, so I'll put the formula back in here. I'm going to put in a formula called get pivot data. And in get pivot data, what I'm going to do is I'm going to refer to the pivot table itself, which starts in A4, and I'm going to subtract from that, or excuse me, I'm going to specify that with respect to the total. And got a cheat here. Yeah, there we go. And I'm going to subtract from that the sum of these 5 cells. So what I did to get the top 5 here and then get the all other was I basically just referred to the cells. I didn't do a copy and paste. I'm actually referring to cells A4 through A8, both for column B and C over here in this new area. And then the all other, I'm calling get pivot data to get the total here and subtract from it these 5, and then what's going to be remaining is the all other. And this chart is actually pointing directly to the range of cells here. And you might want to hide that from the end user so that they don't necessarily need to see that under the hood. And if I were to say change this from Oregon to Washington, well, the all other is obviously very big there because the first 5 cities, even though they're still very high, still don't necessarily account for everything. So just a little trick there if you ever need to do an all other. Okay, moving along here. Another example, and this is what I had to do for a client a while ago and had to help him through this, was implementing a pivot chart with a sparkline and also doing dynamic coloring. There's actually a lot that's going on here. I'm going to go through this. I'm going to go through it kind of quickly, and I'm not going to complete. I'm going to get just far enough so that you'll actually see the end result. So in this case, I'm filtering on the product categories, and I've got a slicer on the year, and I'm going to put the countries down the left, and I'm highlighting the low month in pink and the high month in green, and I've got a spark line out here. And then at the end, I've got a basic pivot chart. Well, I'll concentrate on the spark line and the pivot table up here and the dynamic coloring. So over here in Excel, I will connect to the same OLAP cube that I connected to before, and I'm going to go to reseller sales, and I'm going to select the reseller sales amount. And in the final result here, we filtered on product categories. So I'll come down to the product dimension, and I'll go to more fields, and I'll go to the product category and put that in the filter area. And the end result here is filtering on clothing. And we're going to see a couple of other options here along the way. Well, I want to have a slicer on calendar year. So I will go to the date dimension, and I will expand. I'll go to the calendar area, take the calendar year, and I will right-click on that and add that as a slicer. And in the example here, I was doing the year of 2007. Well, now I'm going to put the months across the top. So I will go under the list of more fields, and there is an attribute here called month of year. I will put the month of year in the column axis. And that gives me the 12 months of the year. And then we want to put the countries down the left. So I will go to the geography dimension, and I'll put the countries down the left in the row label quadrant. All right. Now I want to put that spark line in here, out to the right of the chart. That spark line gives us basically the high-low monthly based upon each country, and just a quick visualization of a trend. Spark lines are compressed charts. All of the labels and any tick marks or anything are stripped out. It's just basically the trend itself. But there's something I need to do before I implement the spark line. The spark line is going to read that range of 12 months. Well, what happens if I pick something like 2008? I'm only going to get 6 months here. I want the spark line, even if it's going to show a blank, to try to do everything it can to show 12 months, or at least to try. Well, I want this pivot table to show me all 12 months, even if it's null for every country. Here's what we can do. By default, the pivot table is suppressing any columns that have nulls across all the rows. I will right-click on the pivot table, go to Pivot Table Options, and in the display area, the display area, I'm going to say Show Item with no data on columns. Actually, you know what? I'm gonna pick both here. Not that it really matters. I'm gonna pick both. I only really need it for the columns. I'm gonna pick both there. Well, that way, if I pick 2008, now I still get all 12 months, even if the last half of the year is empty. Now I'm going to put the sparkline in. Now, a little bit of mouse trickery here to do this. I'm going to insert the sparkline here and come down to the total row, but I only want to do it for the 12 months, not for the grand total. Obviously, it doesn't make sense to plot the grand total against the 12 months. So I will go to the Insert menu, and there are 3 sparkline options here: a line chart, a column chart, and a one-loss chart. I'm going to pick the line chart. Now, I want to know 2 things. What's the range of data we're plotting over, and where's the sparkline going to go? Well, it already knows the sparkline is going to go here because that was the range I highlighted. As far as the data range, I want it to start from here down to here. I'll take OK. Now, it's not all that interesting right now, but let me decorate it a little bit. I will go to the Design menu drop-down, go to the sparkline color, and for the weight, I'll make it a little bit thicker. And for the colors, I can go to, under marker color, I'm going to mark the high point as green and the low point as red. So now we got a quick visualization of what were the high and low months for each country. But we also want to mark the low month and the high month individually with a cell to actually see where it is. Now, imagine we had not 5 countries but 50 cities. And we know that we need to highlight these one at a time and go to the option to do some dynamic formatting. Well, that can be a little bit of a drag. What I'm going to do is I'm going to record a macro that does it the first time and then apply that macro to the other rows. There's a little bit of a trick involved here. What I'm going to do here is I'm going to highlight this list of, I'm going to highlight the first 12 months. 12 months for Australia. And I will turn on the macro. So I'll go to Developer, and I will start recording a macro. And I will call this max highlight, and the shortcut key will be Control-Shift-M. All right, okay, Control-Shift-K. All right, so with that range highlighted, I'm going to go to the home screen, and I'll go to Conditional Formatting, and I'll go to Top Bottom Rules, and I'll go to the top 10 items, but it's really top N, and I'll change this to 1, and I want the top one to be a green field with dark green text. And then I'll stop the macro. So I'll go back to Developer, and I will stop the macro. Well, I also want to mark the lowest month, the lowest non-null month, in red. I'll do the same thing, or I'll highlight this. I will start another macro. So I'll go to Developer. I'll record another macro, and I'll call this one low point. And it doesn't matter what the keystroke combination is here because I'm not going to use a keystroke for it. I'm going to do something else with it. All right, with this highlighted, I'm going to go to Home and then Conditional Formatting. I'm going to go to the bottom 10 items, but it's really bottom N because I'm going to change that to a 1, and I'll use the light red fill. And then I'll go turn off the macro. Now, here's what I want to do. I want to run one macro for the rest of these countries without having to do both the high and the low. I want to do both of them once. Here's what I can do. I can go in under the Developer menu, go to the macros, and actually go edit that low point. I'm going to take the code from the low point, and I'm going to copy and paste that into where the one for the high point was. So after it's done doing the high point, I'm going to paste in the code that did the low point. Now, I only need the stop if true once here. So now that macro where I have the Control-Shift-K is going to do the high and the low for one row all at once. I'll compile this to make sure I can do it successfully and there are no syntax errors. I'll close this and return back to Excel. And now watch this. I'll highlight the 12 months for Canada here, do a Control-Shift-K, and it does it there. And then highlight these and do a Control-Shift-K. I would love to know how to do this across all of them. There may be a way, but this is still at least a lot better than having to do both of them for each country. Okay. And then finally do it for the grand total. So pretty nice capability. Okay, I want to make sure I get through everything else. So I'm going to speed this up just a little bit. By the way, the pivot chart here, all I had to do was just insert a pivot chart. It's going to automatically sense the columns and rows. As a matter of fact, just do this here very quickly. I go to Insert and actually select any kind of a chart. It automatically builds that chart with the months as in the series and the countries as a legend. You can obviously right-click and go change the data in the chart or select the data in the chart and move things around as need be. It's really that simple. All right, so that covers the dynamic coloring and macros. I'm going to talk now about PowerPivot. Now, first of all, before I even get into PowerPivot, I did a session for SQL Pass for one of the other virtual chapters back in September that I want to call your attention to, that goes into PowerPivot and Power BI in a little bit more detail. On my website, which is just kevinsgoff.net, if you take a look at a presentation that I last did just a few weeks ago, Introduction to Power BI for Office 365, goes into specifically Power BI and how you can incorporate it with Office 365. So you might want to pull that one down. That's going to give you a lot more detail about Power BI specifically. The thing about Power BI, this is something that is relatively new compared with the history of Excel. This first came about in the spring of 2010. It allows people to bring relational data or other data mashups into Excel, into what I call sort of the basement of Excel, and I'm just using that term loosely. You can bring relational data into Excel, join it together in basically the equivalent of a star schema, and operate on it from Excel as if it's a cube, because it's basically using an equivalent of the analysis services engine inside of Excel as a source of data itself. So we actually point to data, it loads it into the spreadsheet, actually loads into what I call the basement of the spreadsheet. It's compressed, and then we can slice and dice it as if it's as if we were doing against an OLAP cube. Now, if we bring in data from a some data model, let's say that we pointed to the Data Mart in AdventureWorks, which has fact reseller sales and dim promotion and dim product and dim geography. If you have primary key, foreign key relationships, it will automatically join them together in that PowerPivot model inside of Excel. Now, it's not like the full-blown version of OLAP. It doesn't support all of the relationship types, but it's very good for your basic star schema scenarios. Just to show very, very quickly how that works, I'm not going to get into the full-blown version of it, but if I come here to my starter sheet and I go to the PowerPivot drop-down, I'm going to go to Manage. So I'm not pointing to a source the way I did a minute ago with a cube. And I'm now in what I refer to as the basement of Excel. Well, I'm going to point to a data source, excuse me, from SQL Server, from a database, and I'll put in localhost SQL 2012, and I'll point to whatever database I want to point to, in this case the AdventureWorks Data Warehouse Data Mart. And if these steps look like what you do when you build a cube, that's because of the way they are. It gives me the list of tables, and I'm going to pick just a few of them here. I'm going to pick fact reseller sales, and I'm going to pick the date dimension, and I'll pick the product hierarchy, which is product subcategory, product category, I'm going to pick the reseller dimension, I'm going to pick the geography dimension, and that's all I'm going to pick there. And take Finish. That's reading the data from the data source and loading it in a compressed form into, again, what I call the basement of Excel. So I'll take Close, and we actually see for each of the fact tables the loaded data. It has read the data into Excel. Now, if you're wondering about any relationships, if I go to the diagram view, because the primary key, foreign key relationships were built in the source data, it actually establishes basic joins here. Now, this could be a topic for another day, but notice how, because the reseller sales table was tied to the date dimension 3 ways, as a role-playing dimension where there was an order date key, a due date key, and a ship date key, it only established one relationship there. It does not support multiple relationships the way the full-blown version of analysis services does. You'd either have to repeat that date dimension as a view a couple of times, or write some code under the hood to expose all 3 relationships, but it's not going to support it out of the box. Well, at this point, if I simply come back to the first floor of the spreadsheet, if I select Pivot Table, well, over here in the Pivot Table field list, I can now select the reseller sales amount, which it aggregates, and I can break it apart or select slicers for any of these attributes, just in the same way as I did when I had an OLAP cube, because in effect, I've got an OLAP cube now, sort of a mini OLAP cube that's sitting in the basement of Excel. So this has become a very, very popular and somewhat controversial feature in the data warehousing world. Certainly really opens up the door for what business users can do with data once they bring it into PowerPivot. Now, in many cases, people might want to implement things like key performance indicators and other things that you historically could do with the full-blown version of analysis services. Well, then we get into the issue of what can a power user do with the data with just the visualization tools, and where do you need to write some code. Now, I've got the code here in the slide deck, so I don't need to walk through the example. We might have a scenario where we want to compare employee sales to what their quota was. We might have had a fact table with sales and quota by period of time. And we might implement a calculation of percent of quota both this year as well as a year ago. So we see here that, that Michael Blythe, his percent of quota is 93%, and it's even better than it was last year. Last year was 81%. So, and by contrast, Linda Mitchell here, she's at 89% of her quota. That's good. Her percent of quota last year was 88%. That was okay, or the trend is okay, depending on how you want to render this. Here we need to write a little bit of what's called DAX code. Now, DAX is the language, is the programming language, sort of an expression language that that comes with PowerPivot. It is sort of a hybrid between MDX and the Excel macro language. Again, the other slide deck that I referred to has more details on this. Essentially, let me skip forward here. If I wanted to implement a percent of quota and then a percent of quota last year, well, the percent of quota is not all that difficult. I just simply take the sum of sales amount divided by the sum of the quota and round it to 4 decimal positions. So that particular DAX formula inside of PowerPivot, that's a pretty easy one. But then we get into things like calculating it for the same time period a year ago, so that we can see how we're doing compared to the year prior, or whatever the time period would happen to be. Well, their DAX becomes a little bit more like what you would see in MDX. There are functions for parallel period or same period last year, depending on how you've structured your date dimension, to re-express that percent of quota for the same time period a year ago. Now, I'm going to pull up here the finished version of that. So over here in Excel, close out of this one, and back in Excel, I'm going to open up the final version of that has the KPIs. So this will take just a second to load. So here's the runtime version that has the KPI, the percent of quota last year, and then the trend. Are we going upwards or are we going downwards? So here, J here, 77%. Last year they were at 81%, so they're actually going downward. Well, if I pull up the model for this, if I go to the PowerPivot option and go to Manage and pull up the data model, and go over to fact sales quota. Well, here's the calculation for the percent of quota. It's the sum of sales amount divided by the sum of the quota. But then the percent of quota last year is utilizing the formula the same period last year, or we could have done parallel period to re-express that percent of quota 1 year ago based upon the date dimension. And then for the KPI itself, this has the ability to let us implement KPIs. I could go edit the KPI setting, and maybe we have a rule that that anything 85 and above is good, 75 to 85 is okay, and anything below 75 is bad. So this is somewhat like the KPI editor that you see in the full-blown version of analysis services. Not as much functionality, but at least a slightly better interface. So that gives you at least a partial idea of what we can do with PowerPivot. Now, like I said, that scratches the surface of the surface, but the point is that we can bring relational data into PowerPivot based upon some fact dimension model or however model you want to set up, and then treat it on the outside as if you would treat a cube. Now, in addition, Microsoft has also implemented, and I'm going to wrap up here in about 5 minutes. I know this is going to go to 1 o'clock. If I can have 5 minutes, I should be able to wrap this up. There is a new visualization tool called PowerView. Now, PowerView is a end-user reporting tool that works off of PowerPivot models inside of Excel. It's not a full-blown report writer. It doesn't have all the functionality that Reporting Services does, but it does have some nice visualizations. Now, a very simple example, one that I had built here in just a matter of minutes. I'm going to take that same reseller sales data, and the PowerView interface gives you the ability, first of all, to build bar charts or pie charts, whatever type of chart you want. The charts are pretty basic, but they're functional. And I actually put the bikes as a tile. You have the option to specify a tile here instead of a filter. And then I've also got a second chart here that actually has the sales broken out by country. Now notice how I'm filtering on 2008. And I'm going to click on mountain bikes. Notice what happens down at the bottom. The sales here break out for mountain bikes for 2008 by country. And if I pick road bikes, the sales change. The second chart here is actually context sensitive. The first one is basically some cross filtering that's going on. And it gets even cooler. Watch what happens if I pick United Kingdom here at the bottom. It's going to give me the sales for all 3 bike types for the United Kingdom. So we could have 3 charts on here, pick one, and it'll have a cross filtering impact with some of the other charts that are on the page. Now this is, again, doesn't have the full-blown features of reporting services, but it does have some nice visualizations. Try doing this in reporting services. You're going to have to write some action code, which can be done, but this does it out of the box. Now, if you've been following websites in the press, you might have seen other examples of PowerView. There are some really nice visualizations for things like scatter charts. You can even do animations. I just have a still screenshot of it here, but you have the ability to maybe plot customer count or number of orders against sales if you want to see the impact of one versus the other, and then play the relationships over the period of years. So you can actually click the play axis at the bottom if this were the actual live version. It would actually animate where the plotted points are in the scatter chart between the sum of internet orders and the sales if you're looking to draw some type of relationship between the two. And you could even stop this and actually see a line chart to show where the trend goes. Now, unfortunately, this doesn't. While this has features that are not in Excel or in reporting services, at least not out of the box, there's some things this doesn't do that something like Excel does do. For instance, an analyst might look at this and they might say, "Geez, I'd like to know what's the regression trend line here," or I might want to know what's the correlation coefficient. Or I might want to know what's the slope calculation. Well, PowerView is not going to do things like that. Excel pivot charts will, and that's where we run into one of the challenges with some of these tools. What you wind up seeing when you really dig into some of the functionality is some of them wind up being subsets and supersets of each other. So sometimes you might use this to maybe prototype something that you might implement in a more full-blown fashion in Excel or in reporting services. Might not have all of the glitzy features that PowerView does, but it might be a little bit more functional. All right, two topics left here. Custom MDX and OLAP pivot tables. From time to time, I've needed to put some custom MDX code into a pivot table against an OLAP cube. Now, ideally, the cube should have all of the necessary calculations. But sometimes you might need to put in a custom member, and maybe the cube is locked down, and you just don't have the ability, or maybe you don't have the rights to do it. There is a free add-on. If you just simply Google on OLAP pivot table extensions, or if you just go to OLAP pivot table extend.codeplex.com, there is a free add-in for Excel that allows you to add on MDX snippets onto a pivot table. Here's the end result. So let me go back to my examples here. Let me come down to the MDX, custom MDX example. I brought in the reseller sales, but I wanted to know the reseller sales last year using the MDX function parallel period, and maybe I didn't put that in the cube. Well, with the pivot table extensions installed and registered with Excel, again, it's a free add-on, I can right-click on the pivot table options, and I see the option OLAP pivot table extensions. I put in two MDX formulas in here. Reseller sales last year, which was just simply the reseller sales expressed in terms of the calendar year hierarchy within the date dimension using parallel period going back 1 year. And the nice thing is, if I then want to have the percent over last year, I can have another calculated member where I can refer to that new one. So I can say reseller sales amount minus the new one divided by the new one, and that'll actually calculate it right there in the pivot table. Very, very nice feature. And I've got a pivot chart here where I'm plotting the first two measures as sales. And notice the third one here, the percent over last year, I actually have it on a secondary y-axis. Obviously, we can't plot all of these along the same scale because the first two in terms of dollars are going to be very high, and the third is a percent here. Basically, what I did was I initially just built a chart as a column chart, but then I went to the percent over last year, right-clicked on it, went to change series chart type, and down at the bottom here, I changed that to a stack line with markers and defined it as a secondary y-axis so it's on a different scale. This is a great feature. It's actually been in Excel for a number of years so that we can plot things along different scales. Okay, special type of pivot chart. This one is one I've used as a training example to demonstrate some of the more advanced features in Excel and in pivot charting. This is one where we actually have the scatter chart that I described a minute ago of orders or customer count by city with respect to sales. We want to see how direct is the relationship between the customer count in any one city and the sales. Is it a very strong relationship, or is it not necessarily that strong? Well, in addition to being able to show a trend line here after we plot those points, Excel actually has a couple of ways that we can see the strength of the relationship. First of all, within the scatter chart itself, the full-blown version of the scatter chart in Excel, there's the ability to show both the slope formula and what's called the R-squared factor. The R-squared factor represents the goodness of the fit of the plotted line. The closer the line passes through all the points, closer to 1 is the value. Obviously, you have a few outliers here which take that R-squared factor away from 1. So we have a pretty good fit, but not necessarily a fantastic fit because we have a few that don't necessarily fit right along the line. Well, it's understandable. It's just because you have 3 different cities with 30 customers doesn't mean you're necessarily going to get the revenue for the same. There's another formula we can put in that some really advanced analysts might want, and it's what's called the correlation coefficient. It measures the correlation or the strength of the linear dependency. This one is maybe a little bit more forgiving about 1 or 2 outliers. It comes up with a pretty strong correlation of 0.83. So sometimes analysts will want to see both, the R-squared formula and the correlation coefficient. Now, the very first time I ever built this, it actually took me a while to build. It's not the easiest one in the world. Just to show the end result here. Yeah, I did it in a different color. I brought in a filter for the geography, brought in the customer count and the sales amount, But the chart, the scatter chart, doesn't go directly against this pivot table. As a matter of fact, if you point to a pivot table and you try to implement a scatter chart against a pivot table, you actually get a message that it doesn't work. So what we have to do here is we have to grab the formulas, or excuse me, we have to grab the range of cells and store them off somewhere. Either downgrade them as just regular cells in the sheet, or maybe build a reference to these. Maybe build a reference to those two sets of cells. I actually have some name ranges in here. If I go to the formula area and go to the name manager, I actually have two ranges here called customer count and sales amount that's basically used in the Excel offset function to grab everything in those two columns all the way on down. I have to end somewhere. I know that I don't have more than 280 cities in here, so I just plugged in a hardwired number 285 for the last possible city. So I actually have name ranges for both of those columns. The pivot chart is built. If I actually take a look at the chart here and take a look at the data, if I right-click and select the data, it's actually built off of those name ranges. It's kind of hard. Let me actually expand this here. It's actually built off of the customer count name range and off of the sales amount name range, because you can't do it directly against a pivot table. And then just to simply show the slope in the R-squared formula, that's easy. We can just simply right-click on the series, go to the Format Data Series options, and you know, it's amazing when they change these in Excel 2013. I'm forever losing. This is embarrassing here. Yeah, here we go. For formatting the trend line, I'm showing the option to display the R-squared formula and the equation in addition to the trend line. And down at the bottom here, I've got the correlation coefficient that an analyst might want to see, referencing both those name ranges. So if anybody has any questions more in detail about doing that, because that's a topic in itself, feel free to email me. That's more of an advanced chart that somebody might want to see. I actually had to do that for a client a while back. Now finally, some recommended reading. I'm going to recommend 3 names that if you work in data warehousing, if you work in business intelligence, if you work with Office BI, you want to read, and I'm not exaggerating when I say this, you want to read practically every printed word that they've said. Some people might recognize these names already. Chris Webb, Alberto Ferrari, and Marco Russo. They've written some books together. They've written some books on their own. Their blogs are fantastic. They have great coverage of PASS and some of the new functionality that's coming down the pike in SQL Server. They have done a lot talking about Power BI, about DAX. They still do a lot of work, and they still write on traditional analysis services features, but they certainly devote a lot of their time to Power BI and to PowerPivot and DAX. So I highly recommend these 3 guys. And sometimes I joke and I say they're basically the 3 wise men of Microsoft BI, because I go to their blogs almost before I go to anyone else's. So, well, hour and 15 minutes. It's usually about how long it takes me to talk here. Let me go back to the first slide here, just to get my website and my email address back up here. If you have any questions, feel free to email me. I might, because I'm usually working during the day for some client, might not be able to get back to you right away, but certainly do what I can. My email address is kgoff, K-G-O-F-F, @kevinsgoff.net. And my website blog is www.kevinsgoff.net, and the slide deck is in the download page on my website.
Thanks, Kevin. Okay. That was outstanding.
Oh, thank you. Thank you.
That was a lot of material, and I know I'm sorry about the time. I wish we had more time, everyone, to go over all this. And I apologize for my headset earlier in the presentation. I switched over to the telephone, so I'll have to get a new headset. But yeah, that was great tips. I loved them all. We did have a couple of questions here, and we did have some input by Bob Phillips too. So thanks, Bob, for joining us today and giving us some of your inside tips too. One person just did mention when you were doing your Excel formula to get those $ signs in there, you could hit the F4 key when you have your formula expression highlighted.
I did not know that. Well, you always learn something. I did not know that.
These
Thank you.
Excel functions. Bob Phelps did a follow-up, and he said if you just keep pressing that, the F4, it toggles through and does the absolute relative pass for the dollar sign. So neat little tip.
Yes, it is. I will add that. I will add that every time I do this. Thank you.
I think I did hear Bill Jelen say that one too one time. One question on the when you did the highs and lows on the pivot table chart. When you did the highlighting of the reds and the greens.
Right.
Someone was wondering if you changed the year filter on that, then would you have to redo that?
Yeah, to the best of my awareness, yes. And if someone knows how to protect those, I would love to know, because if I go to that, particular one. Yeah, if I change years or change anything on here, that winds up overwriting. Try to clear everything out of the way here. Yeah, if I pick 2008 instead. Okay. Something's. One second. I got too many things open. All right, try this again. I've got a modal dialog up somewhere and I don't know where. All right, let me start closing some things here. Because it's not.
Oh, it's still on your scatter chart there. It's your Pearson formula. It's updating your formula there. On your correlation.
Oh, that's interesting. Oh, it's. You know what? Here, let me.
I have to hit the escape a few times or something.
Something. I'm not. Yeah.
There you go. Yeah, it's on.
There we go. Yeah. Wow. Okay, try this again. Yeah, if I pick 2008. That's interesting. The slicer retains it, but I think the filter will wipe it out. So I know that something here will wipe it out. Oh, now this is okay. This is how dare this work? I thought that something would wipe it out, and for some reason I'm not able to reproduce it.
It looks great.
I mean that's good that it's doing it, but I thought that when I tried this out before, that it wiped it out and you had to repeat them. Either it was the sequence of how I did the macro, or something else that protected it, because I don't know that there is a native ability to protect those cells when I did the formatting. That's
okay.
Go to home, conditional formatting. I don't think there was an option, and I would love to know the answer to that. I will check on that, and if I find anything, I'll post a blog entry. Off the top of my head, I don't know what the exact behavior is. I would have thought that every time I changed something, it would wipe it out. The one thing you know what, if I pick multiple years here, it doesn't make much sense to pick multiple years, but even that retains it. That just keeps on retaining it.
Bob was saying that it would be a problem if you set up the formula or expression on the filtered data, then remove the filter. Then it would be an issue. So he says he does have some code that resets the conditional formatting when your pivot is updated, and he could send that to you.
Oh yeah, I'd love to see that. Yeah, that's cool.
And you should definitely connect up with Bob Phillips as well. Bob is actually running or in charge of the Excel BI virtual chapter, so I'm sure he'd love to have you do some of this presentation for that as well.
Yeah, I'd be happy to. And I should have. There were other people I should have mentioned, and Bill Jelen was another one. Obviously, he's done a lot of books on DAX and on Excel. A lot of names in here, and even going to a couple of blogs, you wind up finding links to other blogs as well.
Yep, Mr. Rob Colley, PowerPivot Pro, outstanding material as well. So.
Yeah. Oh yeah.
Great. All right. Well, we are out of time, and we should wrap this up. Any parting words of wisdom that you'd like to share with the people before you sign off?
Nothing off the top of my head. Just appreciate everybody attending, and yeah, just keep an eye on what's happening in the self-service area of Excel BI. Even with the power of the traditional tools like reporting services and any dashboarding tools that you build, it's important to keep an eye on what's going on in the self-service BI end, because the functionality is definitely growing over on that side, and certainly the business side of things has an interest in what Microsoft is doing with self-service BI. So developers need to at least have awareness of how people can use Excel.
Great. Well, thank you so much, Kevin. Appreciate your time. Appreciate you sharing your knowledge. This was outstanding.
Sure. Thanks for having me.
Thanks everyone for joining. We'll make sure that this recording gets updated on the YouTube channel later today, and we'll get the content posted to the event site as well. Thanks so much. Appreciate everyone's time.
Okay. Thanks. Have a good day, everybody.
And there will be a short survey when you sign off, or in a follow-up email. So if you could take the time to do that, that'd be great, and give us some feedback. Thanks so much, everyone.
Okay. Thanks, everyone. Have a good day.